Hello world, welcome back to another vsCTF 2022 write-up video. In this video, we'll be walking through the miscellaneous challenge lost assignment. Let's get into it. The final assignment of my digital systems course is to display the digit 4 in a logic circuit. I already finished my assignment in the software, but after I exported the circuit, all data have been reset. I should really take a screenshot instead. Can you help to recover my assignment? Write the message you got in vsCTF XXXX. Okay. So they give you a file and they don't tell you what it is, but we're going to open it up with Notepad++. And you'll notice this is an XML file, but it's an XML file that has circuit data in it. So I did a little bit of Googling and I found out that this is actually a circuit project file for the Logisim application, which I have over here. You can download it from here, and all it is basically a tool for designing logic circuits. So all we're going to do is rename the final assignment to final_assignment.circ for the proper project extension, and then we're going to actually run the Logisim Windows executable here. They have different ones for Mac, Windows, and a Java version for you to download from SourceForge, and that's where I got mine from. So we're going to run it. And now we're going to do File, Open, and we're going to open up the original. I'm not going to open up the recovered just yet because that's actually the solution, and I want to kind of show you what this is all about. So here's what we're dealing with here. This little light right here, or this box you see right here, is what we're trying to get a 4 to show up in. So if you just start flicking on random stuff, you'll notice that different lights, as I like to call them, will start turning on. So depending on how you connect your circuits together through these logic gates here, the lights will light up accordingly. And we need to make a 4, which means this bar, this bar, this bar, and this bar need to be lit up, while this bar, and this bar should be turned off. And the lighter color, I'm colorblind, so I'm not really sure what color it is. I think it's green, but I'm not entirely sure on that. The lighter color means that it's a 1, and the darker color means it's a 0. So 1 being on, 0 being off. So we need to make sure that these connections here, well, you have to figure out which connections go to which of these little light bars, right? You'll notice that there's 7 feeds that go into the light bar because the whole light, or LED, can be represented by 7 bars. So there's 7 feeds going in corresponding to 7 bars. Now you kind of have to play around with it to see which bar corresponds to which feed that goes into it. For example, this bar right here, as you can see, if I turn this on, goes to this lead right here, okay? And obviously more than one of these controls up here, or nodes rather, can control whether this turns on and off. And let's see if we can get another one just randomly. There we go. So this one right here, this feed right here, controls this light bar right here. Okay? Now you'll see these gates on here, and what you can do is you can click this selection tool right here. The poke tool is what you do to switch the switches on and off, but the selection tool is going to tell you, okay, what are these items? So if we select this, we know that this is a XOR gate. We know that this is a NOT gate. This is an XNOR gate. This is an AND gate. And so you're going to want to kind of draw out the different operations depending on the feeds that go in to kind of determine what binary inputs belong up here. So what you're going to end up with is a set of 4 binary values, 7 digits long, that are going to convert to ASCII, and that ASCII value is going to be the flag, assuming you get it right. And you'll know you get it right if a 4 shows up in this LED indicator. Now, I'm not going to go through every single one of these truth tables that I had to kind of work out. You honestly could probably figure this out by guessing, or kind of guesstimation rather, but obviously that's not the preferred way to do it. You want to really figure out how these logic gates work. But again, I'm not going to go through that because it's going to take way too long. I could make a separate video about what each logic gate does and how it works when you feed it certain inputs. As you can see, each one can take multiple inputs. You have to make sure that the logic gate turns on or off depending on what the inputs are. All the inputs that go into it will determine whether it will be switched on and off. For example, I'll give you one example. So let's take this AND gate right here. This feed, and this feed all need to be green in order for this to continue, right? So this line means it's off. These lighter lines mean it's on. So we need this line to be on. And I need to switch back to the poke tool. And you see how it turned colors? That means that this AND gate passed and that this is turned on. Now this is turned off because this is a NOT gate. So it negates whatever input is going into it. So this right now would be a 1, so it negates it, so this is 0. If this were to be a 0, like so, then this would be a 1. And again, you can see that this feed controls this LED bar down here. So if I switch this on and off, I mean, all of these kind of control it. You can correlate the logic gates and the circuit wires to which LED is here. And that's just going to take a little trial and error. Now let's get to the good stuff. Let's get to the actual solution. So what I'm going to do is I'm going to open up my recovered, and this is going to be the actual solution to the puzzle, or at least it was supposed to be the solution to the puzzle. Well, it looks like it didn't save like I wanted it to, so we're going to have to just start from scratch, I guess. That's fine. I remember what it was, I think. So your flag ended up being something like Logi. Okay, so let's go to Google and let's pull up a 7-bit ASCII chart. Okay, so first value we want is a 1. So we're going to scroll down to wherever a 1 would be in ASCII on this third column here. And that's located right here. So that's going to be 0110001. 0110001. Okay. Now you'll notice that this bar came up right here, and that is part of the 4 that we need. And then I think the next value was a 0, so that's 0110000. So 0110000. All right. And then I believe the next one was a capital G, so that's 1000111. So 1000111. Okay, almost done. And then the fourth value, I believe, was a capital I, so 1001001. Okay, that's not quite it, so maybe it was a lowercase I, if I'm remembering that right. 1101001. There we go, that's it. Okay, so your full passcode is going to be 10 capital G lowercase I. So in leet speak, that basically says Logi, which is what this whole challenge was about. I'm not really sure why it didn't save it for me, but let's just save it now and hopefully it saves this time. But there you go. You can see that there's a 4 in this box, and then these values decode to 10GI. Okay? In fact, why don't we go ahead and just go to a binary ASCII converter. I believe it was it that one? No, it was this one. And oh, here you go. So there's your binary values. It's already saved in here from the last time I decoded it. And then there's your flag. So we're going to come in here and we're going to do vsCTF, paste the flag in, and submit. Alright, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular introductions to cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.